Hello space fans and welcome to another edition of Space Fan News. In this episode, NASA will shut down one of its most prolific space telescopes this week. The Spitzer Space Telescope will be decommissioned after 16 years of observing the cosmos. Why is NASA shutting it down, and what's going to happen to it after it does? Well, stick around. So if you stop to think about it, NASA actually has an amazing track record building, launching, and operating space telescopes. Many of them are used well past their nominal mission lengths. For example, Hubble was expected to operate for 5 years, and this year marks its 30th year taking observations. The Solar Heliospheric Observatory was launched 5 years after Hubble, and it's also still up there taking observations of the Sun on the 8,825th day of its mission as of today. Other observatories still operating past their nominal mission lengths include the Chandra X-ray Telescope, the WISE and NEOWISE space telescopes, and there's a great many others. The point is, NASA's gotten pretty good at keeping these telescopes going for a long time, and so it's always kind of sad to see one of them go. This week, NASA's turning off Spitzer, a space telescope that long ago ran out of coolant that allowed it to take deep infrared images of the universe. But it was operated in different modes that allowed images to be taken at slightly different wavelengths in the IR, and this allowed the science mission to continue. Spitzer was launched in 2003 with the aim of taking images of the cold, old, and dusty universe in wavelengths that we can't see here on the ground. Now, the key advantage of this is that Spitzer can see things that are just too cold to emit very much visible light, like gas, dust, protoplanetary disks, brown dwarfs, and, well, it turns out, exoplanets. Now, Spitzer was launched right before the science of exoplanets took off, but it became a valuable contributor to exoplanet studies nonetheless. Now, when combined with images from Hubble, Spitzer data really shines. Okay, so forgive the pun there. The Spitzer Space Telescope also studied the most distant galaxy ever observed. The light from this galaxy left 13.4 billion years ago to end its amazing journey on the detector of Spitzer's cameras. So what has Spitzer done? Well, it made the first weather map of an exoplanet, found hidden areas of star formation, detected a collection of very distant galaxies 12 billion light years away, found the largest known ring around Saturn, was the first telescope to directly identify molecules in the atmospheres of exoplanets. It identified 2 of the most distant supermassive black holes ever seen. It helped detect one of the most remote planets ever discovered at about 13,000 light years away, was the first to directly observe light from an exoplanet, and observed the TRAPPIST-1 system for over 500 hours to determine just how many planets were in orbit around that star. And folks, we got all that and more from a total mission cost, including launch, operations, everything, of $1.6 billion. Total. Given what Spitzer has taught us, that is a real bargain. So it's not overstating things to say that this telescope will be sorely missed, especially since there won't be any observations in this wavelength range until JWST launches sometime this year. For a little over a year, assuming JWST has no more delays and no catastrophes, and I just found out today that there might be, so stay tuned for that, SFN coming up. There will be a gap between what Hubble can observe and what Spitzer was looking at. There's no other game in town, and the infrared is vitally important if you want to learn about exoplanets and the distant universe. So here we are, after 16 years, it's getting harder and harder to point Spitzer where NASA wants to point it, places like the Sun to get the solar panels to charge the spacecraft, and the Earth, which it needs to transmit data to, and of course the universe in general for things to look at. On January 30th, NASA will put the spacecraft into safe mode, which is the lowest possible state of power needed to keep the spacecraft operational, and then it will put it in a sown cone attitude forever. Once done, there will be no possibility of resurrecting it again. After that, the ground system for operating the mission will be decommissioned, and then that will be it for the Spitzer Space Telescope. But all of this brings up an interesting point. After NASA launches, operates, and then turns off these amazing space telescopes, what happens to them? I mean, even though NASA is a rock star when it comes to space telescopes, it's starting to accumulate a lot of decommissioned ones up there, and some of them can stay up there for quite a while. Kepler, for instance, was turned off in 2018 and is still up there following the Earth around the Sun. The Galaxy Evolution Explorer was turned off in 2012 and will circle the Earth for 60 more years before burning up in the atmosphere. Copernicus, one of NASA's first space telescopes, was turned off in 1981 and is still up there in Earth orbit. So all of this stuff is starting to add up. And in the case of Spitzer, it's actually kind of funny how this is going to all work out. It is in an orbit that follows the Earth around the Sun, and it's slowly falling behind with each orbit that we go around the Sun. So in 2051, the Earth will have lapped Spitzer and push it into an orbit which is a little bit closer to the Sun, where it will travel a little bit faster, and then it will pass the Earth by, and then we will follow it for a while. It's really weird. Nice cosmic dance for you. And all of this brings up another interesting idea. Got to thinking about this, and many of us watching SFN are dreading the day when the Hubble Space Telescope is decommissioned, and that day is coming. This telescope has left an indelible mark on our imaginations and has done so much to help us understand our place in the cosmos. Sadly, Hubble will eventually burn up in our atmosphere, but these other space telescopes, they won't. Now, wouldn't it be great if we could get up there and make a little space park out of some of these where future space travelers can go visit them like we do here on Earth with memorials and parks and stuff like that? I think that'd be kind of cool. But wouldn't it also be great if we could somehow push Hubble into an orbit that doesn't decay? I mean, it has that ring on the back where we can grab onto it, and then kind of do the same thing. Put a plaque on it and maybe a little gift shop and a little cafe where you could buy a t-shirt and, get a cup of coffee. I don't know. I think it's a great idea. I'd love to see that happen. But whatever happens, there will always be some relics of astronomical discovery always up there. Dim reminders of technological windows that helped sculpt our vision of our place in the cosmos. All right, well, that's it for this episode, space fans. I want to thank all of my Deep Astronomy Patreon patrons for supporting us. You guys really are helping a lot, so thank you so much. And also, if you happen to be interested in getting some kind of space gear, a telescope, eyepieces, whatever, please click on the affiliate link below to OPT. That is also another way in which you can support what we're doing here on this channel. So thank you all so much for watching. And as always, keep looking up. Other observatories still operating past their nominal mission lengths include the Chandra X-ray Spelloscope, the Chandra X-ray Spelloscope, a spelloscope. Oh, that'd be nice. Other observatories still operating past their